Welcome, my name is Johannes and I'm going to be presenting work that I did with one of my bachelor students, Andreas, on StencilFlow. StencilFlow is an end-to-end framework allowing a novice user to specify stencil programs using a high-level JSON-based domain-specific language, then invoke a simple Python script to map the input to an FPGA platform, producing a fully pipelined, fully parallel architecture exploiting all possible streaming opportunities in the program. StencilFlow is not only for novice users, however. Although an experienced hardware engineer might be able to optimize a basic stencil program within a reasonable amount of time, even a fairly simple three-dimensional stencil, as soon as vectorization involved, becomes extremely complex and verbose, including a lot of initialization management, buffer management, management of boundary conditions when the stencil axes are out of bounds, in addition to just the computations themselves. All of this is generated transparently by StencilFlow, taking the high-level input program, inferring a DAG, which satisfies all the dependencies between the different stencil operators in the program, then performing an abstract hardware mapping, which inserts all the right buffers in order for this to become a fully streamed program, then emitting a dataflow graph using the data-centric parallel programming framework DaCe, which is then lowered to an implementation specifically optimized for Xilinx FPGAs, and finally emitted as highly structured, highly efficient HLS code, which is compiled using the Xilinx Vitis unified software platform to a bit stream that can be executed on the FPGA. To the best of our knowledge, these bit streams yield the highest ever recorded single precision stencil performance on Xilinx FPGAs, such as more than 760 gigabits per second for this diffusion 3D example. StencilFlow was presented at the IEEE ACM 2021 International Symposium on Code Generation and Optimization (CGO), where was awarded both the Results Reproduced and the Code Reusable badges by the Artifact Evaluation Committee. All our work is open source and available on GitHub. Thank you for your consideration.